Hello everyone. Today we will start our webinars for ADA training. And to start, I'm going to have a brief overview of ADA and our webinar training schedule. So first of all, welcome to all of you and thank you very much for your time. In this webinars, we will present ADA, which is a tool for bridge rehabilitation and design. It is based on S6 and it will be used by MTO. This is our webinar schedule. As you see, we will have these webinar sessions for 7 weeks from now on. First weeks and first topics will be simply basic things in ADA like modeling, but continuing these models, we will reach out to more complicated and detailed modeling techniques in ADA and design. We will also cover 3D modeling. And as you see, we will have 2 webinars each week, Mondays and Wednesdays. Here we have an overview of ADA bridge solution. So it has been under usage for 50 years and it is made in Canada. So we have our development team here with us. So if you have any feature requests or questions regarding the calculation, we can always answer you through our tech support. We use S6 Canada code to design the bridges, and we always try to keep our codes up to date. Also, ADA is used by Ministry of Transportation of Quebec, MTQ, and they used this software for design of all new bridges in the past 15 years. It's used by consultants in Quebec also, like IACOM, SNC-Lavalin, WSP, and others. And right now we have one RFP with MTO to replace Canvas for the bridge design. To help you out more for the resources, we have created a website which is a dedicated website for MTO training. So as you see a screenshot of website here, so you will have all of the information available for training material on this website. So as you see, we have videos, FAQs, and tutorials. So you can always refer to website and use it in order to get more training materials. Also, these webinars will be uploaded to our videos section here in order to easy access for you. We will upload the models also with tutorials. So it is a very comprehensive website. So for today, let's start our basic modeling in ADA. In this session, we are going to talk about basics in Advanced Design America or ADA, and we will be familiarized with the graphical user interface, the menus, toolbars, and general things that we need to know to use the ADA and build our models. So as you see here in my desktop, we have Advanced Design America open. This is the first window. So normally we start with a new project, so we click new, or you can use Control M and you will have the modeling space here. You see, we normally start from X and Y 2-dimensional space. but you can always have the isometric view. The simplest way to have that is using the page up button, and you will have a 3D view. As you see here, the menus in ADA, they have completely linear, and the options that we see here, they are standard windows like File, Edit, View, Common, and other options. And normally when we start modeling, it's linear, so we start with Common, Tools, Structure, Loads, Analysis, and Results. So you will not be lost between the menus. The first menu that we have here, it's a file. You can always start a new project, opening, saving, save as, standard, and import export, that you can import files to ADA from, let's say, AutoCAD. You can import your geometry, and also we have a specific extension that's called GTC or GT Greatech extension, that we can import or export models between ADA and Advanced Steel. As you see, we have export also here. The other menu that we have here, the project configuration, which is one of the main dialog boxes in the software. For every project, you need to define this configuration here. For example, we have the general definition of project here, the project number, name, and other characteristics. We have the preferences here. First thing that you need to choose here, and our default is Y, is the gravity axis. So in ADA, you can always change your gravity axis to Y, Z, or X. Our default is Y. And the other tool or option that you have here is display coordinates of nodes, that you have Cartesian here, but you can change it to polar. Here we have the merge tolerance between nodes, and it's mainly it's used when you have so close nodes. Two nodes are so close to each other in the modeling, and that's the tolerance that says to ADA, if two nodes are closer than here, let's say 0.01 meter, ADA will automatically merge those nodes. So here as a default, we have around 1 centimeters here. The other option here is normally we call it a shape designation. So it will decide on the section types and names of the sections that we are going to use in ADA. Of course, you have the unit system, metric or imperial, warning sound if you want to activate it when you have errors or other stuff. You can change it to beep or no sound. Dialog box display. This is an option to control whether when you add a new node or a member, the automatic dialog box to define the characteristics of that member or node. Do you want it to come up automatically or no? So most of the time we deactivate these options because it will make the modeling faster, and you can just draw and draw your elements or place your nodes. And after that, you can double click on the nodes or elements to define the characteristics. These are other default check marks or other default radio buttons here for the ADA. It's for archiving archiving the common objects in the project, compressing files when you when you close or save the ADA, and here you have the number of processors which is default as 8. Here in this tab we have the analysis. For your project, you can define one of these three. We can do linear analysis with release, or nonlinear analysis. This part here is for tributary area calculation according to any code. And if you want to use it, you need to put the check marks here and define your code, or you can just uncheck them. this part here is about the general dynamic loads, loadings and the timing. In this part, we normally define the parameters of analysis. For example, for nonlinear analysis, these are the criteria for convergence. And normally we leave these numbers and defaults as is here, unless let's say in a model we have inconvergence or a problem. In that case, we need to refer here and change some of these numbers. Here, this is for cyclic design. When you are on design, ADA normally iterates for 5 times here according to this dialog box to get the optimized section, and you can always change this number. And here we have the subdivisions for diagrams of moment or shear or other diagrams on beams that ADA automatically divides the member for 10 or here for 20 to draw the diagrams better and with better quality. The other tabs that we have here, like seismic, foundation, steel, composite beam, and other tabs here, we will discuss about all of them in the future sessions. So the most important ones that we need to define for each kind of project would be the preferences and general and analysis. These 3 should be defined at the starting point of every project. Okay. We have the language option here. We can change the language of menus here. We have English, Spanish, and Francais. And so we are going to use the English version here. And the other stuff that we have here, they are all standard windows like print preview and print setup, and you have the exit button here. So the other thing that we can discuss in this session is the views in the ADA. As you see here, we have the view menu here. You have view options tool that we mostly use this. It's very important to check the results, types of elements, what can you see on the screen, the loads here, types of graphics, everything we control from this window. So it's very, very important window in ADA, and the shortcut to bring it up is normally it's just pressing O. So with O, you're going to open the view options window. So for example, I would like to add a note here to start a project, simple project. As you see here, we have different kind of elements here in ADA, and let's say we start with nodes. Normally at the start of project, the node button, this one is automatically active. So clicking this and pressing this plus as add, you will bring up this window, which helps you to add new node. For example, you enter your coordinates here. I'm going to put here 0, 0, and 0. And pressing OK. As you see, we have the node here placed at coordinates of 0, 0, 0. And let's say the other node, I'm going to put it 10 meters, y0 and z0. And as you see, we have the second node added here. But one of the very, very important positive points on ADA is that ADA is based on spreadsheets, and we will see the use of these spreadsheets in the future and the other modeling stuff soon. And you will realize that it's really helpful. You can copy and paste your coordinates or other stuff from spreadsheets in ADA to Excel or the other way. So for example, these nodes that you see here, they can be also added using the spreadsheet. To bring up the spreadsheet, we use a Control H, as you see, or you can go here, Nodes menu, and just press the nodes. So you will see the spreadsheet of nodes here. As you see in this project so far, I have 2 nodes. You have the number of nodes here, the types are normal nodes, and you have the coordinates and other specifications of the nodes if there are any. So if you want to add extra nodes, instead of using this option here, adding a node, you can just go to the spreadsheet of nodes and add your node here. For example, I'm going to add another node as number 3, and let's say its coordinates will be 5 meters on X, 0 Y, and 0 Z. And as you see here, we have the node added here. This is a very fast and efficient way to define your geometry and other node characteristics, but just pay attention that when you press Ctrl H, you should have the nodes activated. First activate the node icon, and afterwards we're going to push Ctrl H to bring up this spreadsheet. Okay, I'm going to build some other members also here for the beams or 2-dimensional members. You need to just click these members, and the members element will be activated, and afterwards you have again 2 options to do that. You either select this as add and add your elements by clicking on them, and here, or the other option is again with Ctrl H or spreadsheet. As you see here, you have another window which is for members, and you have all of the member characteristics here: start node and end node of the member, the end restraints of the node, which can be a fixed or hinge fixed or fixed hinge. You can change all of these here. And also, if you want to bring up the member characteristics window, you can just double click on the node, on the member, sorry, and you will have this window here that you have all of the characteristics of your member here. As you see here, the node, the member number is 1. You have the beginning and end node here. You have the option to change this from the starting and end numbers with this inversion. And as you see here, we have the lengths of the member, and the beta angle is 0 here. Beta angle is the local x coordinates of the member that I will explain it to you later, how you can rotate the member around its axial axis or longitudinal axis. In this window, as you see here, you can change the end conditions of the member. For example, bending mx. In ADA, the strong member is always x local, and the weak axis of the section or member is the y, and z, as you see here, is the axial local coordinates of the member. So this is always the default of ADA, unless you can rotate the member with this beta angle that I'm gonna show you right away. So here you have different options. For example, if I click this drop down menu, you see you have all of the options here. I can put the beginning as fixed and as hinged, or vice versa, or both hinged and conditions for MX or strong axis. You can do the same for weak axis and for torsion. And as you see, we have another option here for axial force. You can define the member to be in tension and compression, or tension only member, or compression only member. So normally we use this kind of behavior in the brace elements, and the default is tension and compression. And here, as you see, we have the properties of the member. Here you can always select the section. We have different kinds of sections here: street, concrete, or timber. For example, let's go with a steel member here. You have different classifications here. Let's go with the W section of 300 by 31068. And as you see here, you can filter this to have more or less sections. As a default, we have the Canada, USA filter, and if you put nil here, you will have no filters. You will see all of the sections. So as we select the W31086, if you click on that, you will see the section properties, dimensions, and moment of inertia, or elastic modulus, and other constants on the section. So we are going to select it, and as you see, it's added here. And the second part you see here is the material. You can define the material. Again, we have different kind of materials already defined in ADA, and you have the option to add custom materials, even custom sections that I'm going to discuss it later. So let's say for now I'm going to select steel. Let's say G40 350. Here is the dead load of your member, that if you select that here, it will be automatically applied to the member. And these are other options that we will discuss about these on the design session. So if I press OK here, my member is defined right now, and I can check this again with my spreadsheet, Control H, and as you see here, I have defined all of my properties here. And you can, again, if you want to modify any of these properties, you can just do it here on the spreadsheet. So to define maybe custom sections or materials, you can always go to this menu here, Common, Materials. As you see here, we have steel, concrete, timber, and aluminum. Let's say for steel, these are the default materials that are already defined in ADA. And we can always add new materials, custom ones here, and use it in our model. For example, the simplest way would be copying and pasting one of these. Let's say I want to build a material from ASTM A36. I just click this row here and right click, and I have an option here as copy, and you can come down here and paste it. As you see here, I have another material here, and now you can modify your material. For example, I'm gonna name it as test, and you can change the characteristics here, and you will have a new material. If I press OK and check the material here at STM, and here, as you see, I have the test here. This is the new custom material that I've defined for this project. So this is how you define a custom material. And also we have the possibility of defining other kind of custom sections. As you see here, we have I shapes, C shapes, and other stuff. So let's say if you want to build a new custom I section, you can easily go here, I shapes. These are the default ones, which I've already defined in ADA, and you can easily build another one. Let's say I'm gonna use again the copy and paste. Control C, Control V, Control V, yeah. And as you see here, you can change the name as just I, for example. You can change this one and the material and other stuff. So you will have a new custom I section. And we have also opportunity to check and view the member. You can always come to one of these cells here, right click and detail, and you will see the properties of the section which is defined here, like section height, BET, and other properties. So this was how we define the materials and shapes, and you can define all of the other elements here. As you see, reinforcement, cables, studs. You can always use this common menu to define new custom materials or shapes or other structural elements. So as you see here, ADA shows these members as lines, but we have the option to view these as 3D members, which is more recognizable. So we go to view options here, or just press O. And here, as you see, we have different view types and how to show things in ADA. For example, as you see, for nodes, we can select that either the nodes will be shown or no. For example, if I uncheck this and apply, as you see, the nodes are not here. Actually, they are here, but you cannot see them. So putting it back like this, you will see the nodes, and that goes for the members. Also here you can deactivate the view or activate them. We have floor, walls, and plates element that we will discuss about them. And in attributes here, for example, if you want to see the menu as the member as 3D, you can always check this option as 3D display, apply, and as you see here, it's showing 3D the member. And also you have other options here. For example, you have the opportunity to see the end conditions. If I put the check mark here, ADA will show you what's the end condition. For example, for this member, as you see, I have hinged ends here, and if you check the member just by double clicking it, as you see here, for bending MX, I have double hinge end conditions, and you see it here. And also, if I come back to options, you can see the local axis. As you see here, the local X is the red one, local Y is the green arrow, and local Z is the blue one. You have other types of view also here, without shape, without material, axial release. It will show you the axial release. You can hide or show the extensions or other kind of view types here. But the most important one is normally the 3D display, that it helps us to know what's going on our model and what kind of sections we have. You may have realized that our nodes are here, but the member just extended up to this ends, and we have some free space here, and actually the member is already extended until these nodes. But ADA has an option to help the user if he wants to see the nodes and the connections and what kind of members are coming to this node much more clear, and you will know that which element is connected to this node. And you can always activate or deactivate this option. It's on here, graphic. And as you see here, we have fraction of L not drawn, and it is saying that around 10% of member here is not drawn in a purpose of just seeing the nodes clearly and seeing the connection clearly. So if you put it 0 and apply, as you see, it will draw the member just from the start node to the end node. But it's preferable to put that back here. To see clearly this node. So as you see here, for our second member here, we did not define any characteristics with control edge. As you see here, it doesn't have a shape. So I'm going to use another option in ADA, which is similar to match properties in AutoCAD. As you see here, we have this reproduce, and I'm going to assign exactly the same characteristics of this member to the other one, the new one. So to do that, you just click on this member and select it, and click our reproduce. Click the second member, and it's done. As you see, this second member have the same exact characteristics of the first member. Okay. So another option that we can work on it right now is the size of the icons or size of the signs you see for the nodes. We can always decrease or increase this size, and we always use this diagram amplitude to increase or decrease those nodes if they're blocking your view or you don't want them to be so large. You can always increase or decrease. And also there's another option. If I go to here, attributes, I'm going to activate the 3D display, and here on the members I'm going to activate let's say member number to be shaped, or member shape to be shown. As you see, I have the member name here, And to control the font and the size of this caption here, you can use these two options to enlarge it or to reduce the size. And these two here is the automatic one that ADA automatically selects it by checking out your model. So view options, and here I'm going to deactivate it. You have other options to do here: numbers, length of member. If you want to see the length of member, you just put it here and apply. Okay, and as you see, it's 5 meters each member. For now, I'm gonna deactivate it. Okay. So we have talked about the nodes, the members. Right now, I'm going to add another type of element here. As you see here, we have plates, we have floors, and we have walls. These are different kind of two-dimensional elements that we can use in ADA. So I'm going to add 4 other nodes here in this project. Let's go with Control H and add my nodes here. Pardon me, we need to use the nodes, and after that Control H. So right now I have 3 nodes, and I'm going to have 2 other to define a plate element. So the other one will be node number 4, coordinate x 0, coordinate y 0, and coordinate z, let's put it at 10, and node number 5, x10, y0, and z10. Okay, as you see, I have 2 extra nodes here, and I'm going to add a plate member or floor member here. As you see, I have the plate member here, so just click it and add, and just click the 4 corner nodes to build this plate element. The finite element plates, it's like shell elements, and you can define them as concrete or steel, and they have their own stiffness. As you see here, if I double click, the plate characteristics will come up, and you can always define all of the characteristics like members. So we are going to discuss about these kind of elements in other sessions. Right now I'm just showing you how to build them and how to draw them. Same thing goes with our floor and the wall elements. They are the same. So to draw them, like just I'm going to delete. To delete this member or this plate element, you need to select it. And to select it, firstly we need to activate these plates. Select it and hit delete button. So it will be deleted. And you can always add this, the floor. Activate the floor member. Add. And 4 corners of the floor. As you see, it is a floor element. And again, if I double click on it, ADA will bring up the characteristics for floors. So here you can again define different kinds of floors, like two-way, one-way, without distribution, joist floors. We have it here. different compositions. You have the characteristics floor here, area, other stuff. And also you can define the behavior of the floor element here. The default is without stiffness, which is just distributing the forces on the edge members of your model or of your floor element. So this is how we define the 2D or plate elements. And the other point that I need to mention here is that all of these nodes you see here, they're free or normal nodes. So they're not supports, and they're not transferring any force to the ground, and they're not supporting anything. So to define these nodes, or one of them at least, as a support, I'm going to delete this shell element, the floor element, because we don't need it right now in this model. And also I'm going to delete the nodes. To select them, you always first need to activate nodes and then select them by window. Okay, to define a node as a support, we can select a node. I'm going to select this node and the other one. And always remember to have a double selection. You can just hold Control. So I'm going to click this, hold Control, and click the other one. So I have two nodes selected right now. And afterwards, I'm going to use Control H to bring up the nodes spreadsheet. And here, as you see, the type is normal. And I'm going to change them. You see, I select the column, right click. You have the replace here, replace to support. OK, and again OK. And as you see, they are now supports. This is the first option, or first way that you can do and define a support. The other way is this. For example, I'm going to bring those back to normal nodes to show you. Select them, Control H, again replace to normal. Okay. The other option, or the other way that you can change those to support, is again selecting those with Control and going to here, this icon. As you see here, this icon, properties. If I see, you have the characteristics here, and you have a node type option here that you can change it to support. Again, it has the same effect here, and you will have your supports defined on those nodes. Okay. So also we need to define the constraints and the supports, because right now they are supports and they are not anymore nodes. So we need to activate the supports, double click on it, and the window will come up. You see here that all characteristics and coordinates of the node. And if you go to this tab, support, here you can define the conditions or constraints of the node, for example, Rx, Ry, and Rz. You have the opportunity to change them to free, fixed, elastic, or second modules. That normally we use fixed, or choose as elastic spring. You can use elastic and define the stiffness here. So right now I'm gonna just leave them as fixed. And as you see, Ry, Rz all fixed. And here you have the rotational constraints, Mx, My, Mz. And these constraints are all on global coordinates. You have the release here in case of if you want to model an uplift or other kind of behavior. You can always use this minus or plus to release the support in one direction. So I'm gonna hit OK, and for the other one also you can double click and we're going to have the same options. This is how we define our supports and the constraints on ADA. So the other subject that I'm going to discuss in this session is copy paste of members in ADA, which is very handful and useful to regenerate members. So to do that, we normally, let's say I want to copy these two members 5 meters on Z coordinates. So you just need to click members, select, and either you can go to edit, copy, or you can hit Ctrl C to bring up the copy and paste. And as you see here, we have different options. You have translation, rotation, mirror, parallel. So for this case, I'm going to translate them on Z, DZ for 5 meters. And you hit OK. And again, you can push just Ctrl V or go edit and paste. And as you see here, I have the members along with the nodes and nodes they're copied. So this is a very, very easy way to copy the members or nodes or even the two-dimensional elements. And you can do like, for example, right now I can select all of these members here. Like it's a kind of a AutoCAD selection. So I select all of them, Control C, and I want to translate them to +5 y-axis. So I'm gonna put y 5 meters, OK, and Control V. So you have the new copied members here. We have also, to help you to better navigate in your model, I'm going to show you our view options here. As you see, I normally use G shortcut to see the isometric view of my model, and you can always hit page down. Page down will bring up the elevation XY, and your home will bring up the elevation YZ, and the end button, it's the planar ZX view. So these are the shortcuts that you can use to navigate your model. And to do a dynamic rotation, you can always hold Shift and the middle button of your mouse. As you see, we have the dynamic rotation here. So you can easily rotate your model. Okay, so we discussed the copy and paste. And okay, we have also the option to move or displace a member. So we select a member, and we can go always to tools. And nodes, nodes, and you have the translation here. So actually we translate the nodes and members will be translated with the nodes. So I'm going to select the nodes here for this member, and we go to tools, nodes, translation, and let's say we want to translate them on Z for 1 meter. And as you see here, the member is translated. So this is another option if you want to translate a node or a member along the nodes. You can always use that option. This concludes our session today. Thank you very much.